Alright, this is Ken Rosever. We're going to talk about Independent Events Basic. And just to motivate the discussion, I'm going to use the example of roulette. You really can't have a discussion about probability without eventually talking about, games. Because games are where you see this kind of probability used on a daily basis. I'm not advocating gambling here. I am saying that I can use this to demonstrate some of the principles. So here we go. If you were to play roulette for fun, maybe at a fundraiser or something, they had one of those casino nights and you got to play, you would find that there are many different ways you can bet. You can bet on the first 12, which are all these numbers from here over. Okay, they're in that block. You can bet on the second 12, the third 12. You can bet on the columns. Each of these columns you can bet on, or these rows, because I have it sideways. You can bet on these rows, sets of 3 numbers. You can bet on the odds. You can bet on the evens. You can bet on black or red. There's an equal number of black and red, though they aren't assigned every other one. You can actually bet 2 numbers at once by splitting like that, or you can bet 4 numbers at once by putting the chip there. So lots of different ways. If we ignore the 0 and double 0 possibilities, which we will, I'm going to ignore those. So let me just cross them out. There's basically a 1 in 36 chance of winning if you bet a single number. And so let's say you decide to bet the first 12. Okay, so you're betting this rectangle again. In that rectangle there's 12 numbers, and so the probability of you winning on your bet, so you place your bet here, you have a 12 out of 36 chance, pretty much. It's actually 12 out of 38, but we're ignoring that. So you have a 1 in 3 shot. Alright, that's your chance of winning. We'll call winning on the first 12 numbers event A. So that's P of A. Let's look at a second bet you might make. Let's say you bet the odd. So you put another chip over here on the odd, and essentially if any of the odd numbers come up, you will win. So let's call that P of B, and let's figure out the probability. So B is going to be the event of the wheel stops with the ball on an odd. And well, half the numbers are odd, so you have a 1 in 2 chance. So my question then is, what's your chance of winning on both bets? You have a 1 in 3 chance of winning on this bet over here. You got a 1/2 of winning on your odd bet. What's your chance of winning on both? Well, in order for you to win on both, the number the ball lands on has to be part of both sets. It has to meet both conditions. So let's look in here and find which of these are both numbers 1 to 12. So we're just looking in this box, and they're also odd. And as I look, I see this one here, 3, 5, 9, 7, and 11 are all odd. So that's 1, 2, 3, 4, 5, 6. So P of A intersect B is 6 out of 36, or a 1 in 6 shot. Now you might not notice it, but I'm going to draw your attention to it. I want you to take 1/3, which was P of A, and 1/2, which was P of B, and I want you to multiply them and tell me what you get. So I'm asking you to do 1/3 times 1/2. And multiplication of fractions, you should know how to do that, is numerator times numerator, denominator times denominator. So when you do that, you get 1 over 6. These are the same. Is that a coincidence? No, it's not. It's a rule for independent events. And they are independent events. There's a rule out there, and it says for independent events, the probability of the intersection, you scroll down, for independent events, the probability of the intersection is equal to the probability of the first event times the probability of the second event. That's always true. I could demonstrate it with something else, but we're going to go on to problems like the ones you'll see in ALEC. So remember that rule. First example. Suppose that A and B are independent events. So we have that rule, and we're going to keep it in mind that P of A intersect B is equal to the product of P of A, sorry, that's messy, and P of B. Okay. So we have independence event such that P of A complement, or P of not A, is 0.5. So if P of not A is 0.5, well, P of A, its complement, is also 0.5. That's easy, because they have to add up to 1, right? And P of B is 0.60. So then, what is P of A intersect B? Well, that's easy. Using the rule, it's 0.5 times 0.6. It's 0.03. So that's my probability. I'm going to stick it in here, 0.03. If that's my probability there, then isn't this, is that right? No, that's not right. It's not 0.03. Good looking out. I'm sure one of you caught me on that. It's 0.30, right? 5 times 6 is 30, and we have two numbers after the decimal place, so that makes 0.30. Okay, so this is 0.3, and if that's 0.3 and this is A, then the rest is 0.2, and this is B, and the rest is 0.3. So the probability of my union then, adding up the regions of the Venn diagram, regions 1, 2, and 3, is going to be 0.2 plus 0.3 plus 0.3, which is 0.8. You don't have to do that though, because we know that the general rule is P of a union of two things is P of the first plus P of the second minus P of their intersection. So that's 0.5 plus 0.6 minus 0.5 times 0.6, which we already figured out. Minus 0.3. 0.11 minus 0.3 is 0.8. So you get the same thing either way. Pretty straightforward. Let's do another one here. This one is giving me P of not A again is 0.40. So if P of not A is that, P of A is 0.6. P of B is 0.10. So P of their intersection is 0.6 times 0.10, which is 0.06. So now I can simply go for the union, P of A union B, using the formula and filling it all in, 0.6 plus 0.1 minus 0.06 is 0.64. And that would be my answer there. Alright, what we're going to do now is we're going to try one more from Alex. And just so you can see it done in the calculator. Here we go. So we're going to go here. And this is Independent Events Basic. And here it is. We have P of not A is 0.3, so P of A is 0.7. Let me get my calculator ready. I'm going to put in 0.7. And P of B is 0.2, so I'm going to multiply that point by 0.2 to get 0.14. That is my intersection. Now, I'm going to figure out the union by taking not 0.3 but 0.7, because that is A, plus 0.2, which is 0.9, and I'm going to minus 0.14 to get 0.76. Very, very easy. I hope none of you have trouble with this. And that is it. See you on the next video. Bye.